All right, welcome back, guys. Unit 11, days 5 and 6. Quick review from last unit. Long division. I know your favorite, right? So let's practice this. X plus 1 outside. We've got x squared plus 4x plus 3 underneath. So remember the goal here. What we have to do is we have to figure out x times what is x squared. So we made this kind of easy. Obviously, that's going to be an x. So now what do we do? Well, now we're going to multiply that times both of these. So x times 1 is x times x is x squared. Very important here. After you multiply, you subtract. So we're subtracting both of these terms. That means I'm going to negate both. Well, this should always cancel. 4x minus x is 3x. And then we're going to bring down the next term. So 3x plus 3. Again, ask yourself, x times what is 3x? Well, again, pretty easy. That's a 3. 3 times 1 is 3. 3 times x is 3x. Technically, we haven't finished the problem yet because now we need to subtract. Well, if you notice, I get a 0. So the quotient is x plus 3. This, if you remember, is what's called a remainder. Well, since there was no remainder here, that means x squared plus 4x plus 3 was divisible by x plus 1, or x plus 1 is a factor of x squared plus 4x plus 3. So in general, if the remainder is 0, then the divisor is a factor. And we have p of a equals 0. All right. First two examples here. We'll only do these two, then we'll move on to the back. Determine if each of the following are factors of p of x equals x cubed minus 2x squared minus x plus 2. So remember, factor, yes. The remainder equals 0, no. Remainder does not equal 0. So we're going to do long division. If our remainder is 0, the answer to this question is going to be yes. If the remainder is not 0, then the answer is going to be no. I'm not really concerned about what the quotient is here. All right, so we've got x plus 2. And then underneath, we've got x cubed minus 2x squared minus x plus 2. So once again, what we're going to do is we're going to ask ourselves, x times what is x cubed? Well, that's going to be x squared. X squared times 2, 2x squared. X squared times x, x cubed. Now be careful here. We haven't subtracted yet. So when I subtract, I negate both. This gives me negative 4x squared. They don't cancel. Bring down our negative x. Ask ourselves, x times what is negative 4x squared? So that's going to be a negative 4x. Negative 4x times 2 is negative 8x. Negative 4x times x is negative 4x squared. Now again, be careful. We have not subtracted. When you subtract, since both of these are negative, you change both signs. So that cancels. This would give me 7x. Bring down to 2. Ask yourself, x times what is 7x? That's going to be a 7. And now we multiply. 7 times 2 is 14. 7 times x is 7x. I have not subtracted yet. In doing so, I end up with a negative 12. So clearly here, the remainder is not 0. So the answer to the question would be no, because the remainder does not equal 0. All right, let's try the next one. X plus 1. Is x plus 1 a factor? Well, let's go to our long division, find out. Okay, x times what is x cubed? Well, that's going to be x squared. X squared times 1 is x squared. X squared times x is x cubed. Now subtract. Those drop out. I got negative 3x squared here minus x. X times what is negative 3x squared? Well, that's going to be negative 3x. Multiply, that gives me negative 3x. And that gives me negative 3x squared. So when I subtract, I negate both of those. Those drop out. I have a 2x here. Bring down plus 2. X times what is 2x? That is a 2. 2 times 1 is 2. 2 times x is 2x. Subtract, and everything cancels. So since my remainder is 0, the answer to this question is yes, because the remainder is 0. So to determine whether something is a factor of a polynomial, you do long division. If the remainder is 0, yes, it is a factor. If the remainder is not 0, no, it is not a factor. Okay, so now we're going to apply this concept, but let's talk about the roots. So it says here, using the factor theorem, determine if each is a 0 of the polynomial. So now let's think about it. X equals 2 is a root, potentially. So if that's the root, then the factor would be x minus 2. And remember, when we do long division, that polynomial, or the factor, has to be outside the symbol. So now I've got my x cubed minus 2x squared minus x plus 2, and we are going to do some long division. All right, so again, here's the process. X times what is x cubed? Well, that's x squared. X squared times negative 2 is negative 2x squared. X squared times x is x cubed. Negate, well, everything cancels, so I just have a 0. I'm just going to bring down my negative x plus 2. Ask yourselves, x times what is negative x? Well, it's negative 1. Negative 1 times 2 is positive 2. Negative 1 times x is negative x. Now subtract, signs are opposite, you've got a 0. So since 0 is my remainder, then I know that x minus 2 is a factor, and if x minus 2 is a factor, then x equals 2 is a root. So yes, x equals 2 is a 0 for the same reason x minus 2 would be a factor, because the remainder equals 0. Okay, let's try one more. X equals negative 3. That's my root, or I'm trying to determine if it's the root. So the factor would be x plus 3. So let's do some long division. X plus 3 on the outside, x cubed minus 2x squared minus x plus 2 on the inside. So what we're going to do now is ask ourselves, how many times does x go into x cubed? That is x squared. X squared times 3, 3x squared. X squared times x, x cubed. Let's subtract. I get negative 5x squared. Bring down your negative x. Ask yourself, x times what is negative 5x squared? That's going to be a negative 5x. Negative 5x times 3, negative 15x. Negative 5x times x, negative 5x squared. Change your signs. Now I'm subtracting. Okay, those drop out. I get 14x. Bring down your 2. Ask yourself, x times what is 14x? Well, that's obviously 14. 14 times 3, 42. 14 times x is 14x. Now we subtract. Those drop out. What do I have here? Negative 40. So, is x equals 3 a root? Well, no, because the remainder does not equal 0. It's not a root, because x plus 3 is not a factor. Now, something that's kind of cool here, I'm going to just fill this in for the sake of time. If you were to put p of x into your calculator in y1 and fill in this chart, that's what you would get. All right. So if you notice here, x equals 2. My remainder was 0. X equals 2. My remainder was 0. For the next one, x equals -3. My remainder was -40. So when x equals -3, my remainder was -40. So this is a very powerful theorem. Okay, and it's called the remainder theorem. When a polynomial is divided by x minus a, the remainder is the value of the polynomial evaluated at x equals a. So basically, it gives us the y value of the function when x equals a. So let's take a look at that very quickly. Find the value of each using long division and the remainder theorem. All right, so I want to find the value of f of 3. Well, let's kind of work backwards. F of 3 means x equals 3. If x equals 3, that means x minus 3 is our factor. So basically, this is what I'm going to use in long division. I know this gets a little confusing because it's going to be the opposite of your x value. So in long division, I'm going to have x minus 3 outside the symbol. Underneath, I'll have 2x cubed minus 3x plus 7. So now, how many times does x go into 2x cubed? Well, that's going to be 2x squared. Multiply by -3, it's going to be -6x squared. 2x times x is going to be 2x cubed. Negate. Those drop out. So right here, those are not like terms. I'm just going to bring down 6x squared minus 3x. Okay, so then ask yourself, x times what is 6x squared? That's going to be 6x. 6x times -3 is -18x. 6x times x is positive 6x squared. Then I negate, so those drop out, and this is going to give me 15x. Bring down your 7. X times what is 15x? Well, that's 15. 15 times -3 is -45. 15 times x is 15x. Now I negate, my remainder's 52. So since the remainder's 52, that's the y value of the function when x equals 3. So if I'm evaluating a function, f of 3 is just 52. I don't want the quotient, I don't want the yes or no, I just want the remainder. Okay, last one. F of -4. So if I want to evaluate that function up above at -4, what this here says is, okay, I want to evaluate this when x is -4. Well, that means the factor is going to be x plus 4. That's my factor. That's what I'm going to divide in. So I've got x plus 4. And then I'll just write that function down again, 2x cubed minus 3x plus 7. And ask yourself, x times what is 2x cubed? That's going to be 2x squared. I'm just going to go through quickly here. So that's going to give me 8x squared. That's going to give me 2x cubed. Subtract. Not like terms, so I've got -8x squared minus 3x. X times -8x. So -8x times 4 is going to be -32x. -8x times x is -8x squared. Negate. So what do we get here? 29x plus 7. And x times what is 29x? Well, that's going to be a 29. All right, so I've got 29 times 4. So what's that going to be? 58 and 58, 116. And 29x. And then I'm going to subtract. Okay, so that drops out. This is going to give me -109. That is the remainder. That's the y value of the function at -4. So that's going to be -109, and that is just your answer. Again, you don't want any of the division. That's just the work that gives you that y value. Okay, so I know that was brief. That is the note. Those are the notes for days 5 and 6. Once again, please do the associated homework for these days. Check all the keys, and please use Schoology to do the rest of the work sessions and the review. Thank you.